All right, so AKS AKS updates. There was a recent week, but there's a GitHub repo. I believe it's GitHub. It's /Azure/AKS. You can find all like the details on release notes there. You can also find our entire roadmap there. But some of the highlights, you can now mutate the AKS default storage class. We also now support the DV4 SKU. Also, just to be aware, as 1.19 does become GA 1.16, or 1.16 will deprecate, but we will not do that during kind of the holiday season. It's being pushed off to the end of January before 1.16 will actually be deprecated. So during the holiday time, this does not impact you. Also to be aware, once we will start defaulting to using containerd rather than the Moby runtime that we use currently with 1.19 and greater, once containerd does GA. After the GA of ephemeral OS clusters, that will also be the default whenever you create a cluster. So this will use for the OS disk, it will use the ephemeral drive that is created with the virtual machine. This will help definitely from a performance impact. A lot of times what people get into is they get into a performance impact because that OS drive gets rate limited. The rate limits on like the default size of like 100 gigs is very small. It's like 500 IOPS, where you get much better performance from that ephemeral drive. And also to be aware of, pod security policies retired on February 1st, 2021. The replacement for that is using the Azure policy for Kubernetes, which implements Gatekeeper, which I believe Lachie will probably mention in his discussion. Ecosystem updates. HashiConf was last week. One of the things they announced was what's called Waypoint. They describe it as Waypoint provides a modern workflow to build, deploy, and release across platforms. Waypoint uses a single configuration file and common workflow to manage and observe deployments across platforms such as Kubernetes, Nomad, ACI, Google Cloud Run, and EC2, and more. Definitely check it out. I only got to play with it shortly, but it gives you a much different experience from kind of a build, deploy, and release, for example, for Kubernetes deployments. So it contains that entire workflow on a very easy configuration file. It also can use things like Heroku's build packs, but it's definitely a very interesting project, so keep your eye on that. A few things to be aware of kind of in the ecosystem that I think people are going to start running into quickly. One of the things is, I should have said Helm had their 5th birthday, which is like 20 years in the Cloud Native world. They will now be hosting the stable and incubator charts on GitHub. Before they were deprecating, and you shouldn't necessarily use these charts. You should really go to Artifact Hub. But some people with like still doing upgrades in that still need access to those stable charts and incubator charts in that repo. Majority of them have kind of moved off into their own repositories, that some of the open source projects where they did host them within that stable and incubator repo, they've now moved those off into other areas. But just be aware of that. Docker Hub. I think I mentioned this probably in previous ones, because this one is probably going to be very impactful to users. At least I'm guessing it's going to be like Doomsday November 1st. This is when these things go into effect. So one of the things is they will mark images as inactive. So if you have images up there that haven't been pulled or pushed within 6 months, that image will be marked as inactive, which means inactive for deletion. So it will no longer be there. I think the biggest issue is going to be coming into play is going to be rate limits. Rate limits for unpaid accounts is going to be for 100 pulls an hour for unauthenticated users. So from say a single IP address, if you were to try to pull that same image 150 times within that, or we'll say 101 times within that hour, then you would get rate limited. It will be 200 pulls for authenticated users. So you could think where this could impact you is if you're going out through a proxy, say in your corporate environment to pull down these images, it's going to have that single IP address. So be aware of these different rate limits. All right, well, I went to the next slide very quickly, but I'm going to hand it over to Lachie Evenson, who is our fabulous guest today.
Fantastic. Hello, Dave. Hello, everybody. Can everybody hear me?
Yep.
Fantastic. All right, I'm just going to share the slides here. Let me know when you can see them.
Yeah, they're up.
They're up? Okay, Upstream Sampler. Okay. Hello and welcome. First of all, I want to say thanks to Dave and to Kendall for inviting me here today. It's a pleasure to be here and to speak with you all and share what we're doing and the problems we're trying to solve. So I have an exciting Upstream Sampler, as we like to call it. It's a box of assorted chocolate. So imagine Forrest Gump here. We're going to go on a journey together to take you through some of the problems that our team is solving via open source. So feel free. I'll kind of monitor the chat. As Dave said, let's keep it a dialogue. I want to dig in where folks are interested, or I can just plow through a complete sampler of everything that we're doing. So I think I have 25 odd minutes here. It's going to be a great journey, and hopefully there'll be something here for everybody. I like to start with this. This is Dave's favorite slide, and if he was unmuted, I'm sure he's laughing right now. So the cloud native ecosystem is extremely complicated. There are lots of projects out there trying to solve a lot of problems in the ecosystem that almost everybody has as they're taking this distributed microservices on Kubernetes journey. So what our team tries to do is actually get in here and help you on this journey by building tooling that makes it easier to adopt these things. So I'll get into that, but it's a good like shock sticker value. Now I've got everybody's attention. What the heck is that? Go and take a look at that. There are projects being added each and every day, and they are all important projects, and they're trying to solve problems in this ecosystem, but it is a complex ecosystem to navigate nevertheless. Who am I? My name is Lachie Evenson. I am an upstream PM on the Azure application platform team. So I work under Gabe Monroy, and I sit beside the other application platform services like AKS, app services, functions, and we have a dedicated team that's staffed to solve problems via open source. So I'll go into that and share a bunch of solutions that we're building today that you can share. If you're in the ecosystem, if you're a customer, if you're a community member, you can pick these up and use them today. I'm a CNCF ambassador, so you'll see me around the ridges. If you have any CNCF related questions, obviously happy to answer that. And I have served both as a Kubernetes release team lead, and I was very sad to hear that Kubernetes 1.16 is being deprecated because that was one of the releases I worked on. I'm also working on 1.20. I worked on Kubernetes steering, so if you're ever interested in how Kubernetes operates, I have a pretty good grok on that from serving in the steering role. And I've done a lot of work with Helm, so I've contributed to Helm. I'm a maintainer, and I've built a lot of charts. So all this to say, if you have any cloud native questions, feel free to ping me. I'm at Lachie Evenson on Twitter, at Lachie83 on Kubernetes Slack, or you can find me on Teams if you're internal to chat to you and help you through your journey. So that's me. Now you know who's talking to you. We'll get into it from here. So our team is pretty unique in Azure, I think. I know that there are other teams starting to do this, but our team builds solutions via open source to enable cloud native developers. So what does that mean? We take a look at the ecosystem and we identify gaps and opportunities to fill integration points between tools and where things are challenging. And you'll see some projects today. Our team also takes care of things like the Azure provider, upstream Kubernetes changes, container runtimes. So we staff a PM and an engineering team that takes care of a whole swath of tools, broad swath of tools in the ecosystem. And some of the outputs of the work we do go into making sure that, you know, AKS is ready to consume Kubernetes versions, that there are features there that customers want. We particularly dig into those things. So there's a broad swath. You'll get a grok of exactly what we do as I go through the sampler here. Okay, I figured I would do some interesting things first and highlight some new additions projects before I dig into the broad swath of things we have done over the years. Two projects that are interesting and kind of niche at the moment. One is called Cubelet. So Cubelet was developed out of this need. We saw a lot of interest from customers to run Kubernetes on edge devices. Now, when they look into running Kubernetes on edge devices, more often than not, those edge devices are really resource constrained. And those edge devices are things like Raspberry Pis at the best, or even smaller devices. So it's okay to run Cubelet on the edge, obviously, but container runtimes become really bloated. And believe it or not, containers become really big. So one of the things we looked to was actually using WebAssembly, which is a different way to package and distribute binaries and applications, and rolling that up under Cubelet. So what this means, what Cubelet allows you to do is run WASM via Kubernetes on your edge devices or anywhere. So if you're interested in that game, or you have customers, or you're in the community interested in digging into WASM, there's a project there where you can run WASM via Kubernetes. So that's a cool project. That's called Cubelet. You can check it out at the link there. And one that was released, I believe, Tuesday of this week is called Akri. And this is a super interesting project. It's not out of our team. It's actually out of the IoT Edge team. And what this does is, remember back to the days of plug and play, where you would have a PC and you would plug something in and it would detect it and say, I can use this device, you know, that wonderful world where that used to be really complex. Well, Kubernetes is still pretty complex like that. So if you have an edge device and you want to plug a sensor into it, a camera into it, some external storage, it's really hard to actually get Kubernetes to utilize those things. And what Akri does is wrap a standardized interface around detecting and advertising these devices to Kubernetes so that you can utilize them. So it's a really cool project. It's plug-in based. It was actually featured at the Edge Cloud Computing. There was a talk on it yesterday or the day before, but you can go and take a look at Akri. And I must say, github.com Deus Labs. Deus Labs is actually unbranded Azure open source, and we put open source out there that's destined that we would like to have in open source foundations. So typically we hold them there, build communities, and then one day donate them to foundations. For example, the CNCF might be a place we donate them. So if you see Deus Labs, it's an Azure unbranded open source holding tank for things that are intent to go to open source foundations, and it's easy for us to move them over if that's the case. So those are two new additions. I also wanted to highlight, before I dig down into individual projects, just some really cool security integrations. So I think about these integrations as solving big security needs for enterprises. So if you're an enterprise and you have security issues, or you have security officers saying, how do we take care of this? Here's two projects that might help. One is called Secret Store CSI Driver, and that's a big name, but it does something very simple, and it does it in a really effective way. It allows you to mount Key Vault back secrets, or any secrets provider that there's a plugin for. So there are different secrets providers for different clouds. HashiCorp Vault is a provider. You can pull those secrets and mount them into your pod at runtime and not store them on the VM disk or anywhere. It's just a RAM disk. You load them in, and you have access to them in your pod runtime, your container runtimes there. So it's a really powerful tool to not store secrets in your Kubernetes cluster while you're running on disk, and to be able to authenticate and pull them in. That's a cool tool there. One very cool feature that I don't know if it's landed yet, it's gonna land soon. There's actually auto cert rotation. So let me give you a really cool use case here. Certs are a pain in the butt. Nobody's gonna argue with me about that. Nobody ever has, and nobody ever will. I've been woken up, you know, at 12:01 when a certificate has expired because somebody typed an arbitrary date into a certificate, and didn't monitor it, and it expires and the whole, your whole app breaks. Everybody knows that. It's a horrible scenario, but Azure Key Vaults actually implemented auto cert rotation. So what this allows us to do is we can pull in a secret from Azure Key Vault, a certificate, mount it into your pod, serve it, for example, on an ingress controller or something that needs SSL, and call a function to do an auto rotation whenever that happens and pull down the new certificate and load that in, zero touch. So that's a really cool feature. If it's not there, it's coming soon. Having auto rotate certificates will be a massive benefit for customers and the community alike. So if you're using Azure Key Vault, you can have that out of the box. If you're using HashiCorp Vault, you can pull secrets out from different secrets providers. So go take a look at that. You can run it on any Kubernetes cluster anywhere that is upstream compliant. So that is not an Azure specific thing. We just have an Azure Key Vault plugin there. The other one is AAD pod identity. What we hear from people in the community and customers is, hey, I have a Active Directory, Azure Active Directory. How do I make those identities somehow visible to Kubernetes so that I can have essentially service accounts that give me access to different cloud resources? And the answer is we have a project for that called AAD pod identity. And what this allows you to do is map AAD identities to Kubernetes applications. So depending on how your Kubernetes cluster is set up on Azure, I'll speak specifically, your services might inherit the identity of the VM that they're on to actually access different cloud services. You can change that so that they can inherit their own discrete identity so that when they're authenticating to a service, for example, a SQL database, SQL Server database, or a MySQL server, you can use the correct identity and have the right authentication and roles set up to make sure that that access happens. So that's another project. They're both on GitHub under Azure. If you're interested, go and take a look. Again, they will both work on any Kubernetes clusters. The only thing you need for AAD pod identity is actually Azure Active Directory somewhere. So they're great security integrations for identity and for storage of secrets. Any questions so far? I know I'm going fast. I don't see any. We're good? Cool. Okay, so I'm now going to go through just a wide swath of the projects that our team has worked on and continue. One is Helm. Probably everybody's familiar with Helm. Helm is a package manager for Kubernetes. As Dave mentioned, it's 5 years old. I'm going to give you a couple of other tidbits on Helm right now. So Helm allows you to manage your complexity by wrapping up an app, allowing you to have operational verbs like install, upgrade, uninstall, rollback, and allows you to store things in chart repositories, which Dave was mentioning, to share application packaging. So think of it like, apt on a Linux box or Winget on a Windows machine. You can publish different applications and other people can use them and you can share them and reuse them. So Helm allows you to do that in a Kubernetes friendly way. AAD identity work on Linux? Yes. Okay, the thing I wanted to call out here is Helm 3. So Helm 3 has been out for some time now. Now, if you're using Helm 2, we have an EOL for Helm 2 coming November 13th. So that's only in a couple of weeks. The interesting thing is we've done a lot of work with the upstream community. So if you weren't aware of this, there are lots of resources. We've written guides. I sat on a call for 2 hours yesterday and walked people through the migration tools from Helm 2 to Helm 3. So I've added a link there to the YouTube video on migration and how you can go about migration. There's lots of great resources and documents. But if you're using Helm 2, it will no longer be supported as of November 13th, and you need to move to Helm 3. So just to keep that in mind, that's the biggest call I want to make there. And Helm 3 has a lot of enterprise security features. For example, the identity and root privileges that were needed in Helm 2 are no longer needed in Helm 3. So if you're working with Helm 2, please go and take a look at Helm 3 and consider moving off Helm 2 as soon as you can. Brigade is a project in the CNCF as well. It's in the CNCF sandbox. Brigade is a very, very cool lightweight project that allows you to write lightweight workflows in JavaScript and have them be interpreted and expressed as Kubernetes resources under the hood. So one example I've seen for Brigade is, hey, somebody built their own checks integration into GitHub to go do some special things and actually pass back a green check mark. And Brigade allows you to build arbitrary workflows and have different gates, and you write these things in JavaScript. So the The issue we were trying to solve with Brigade was, can we have a workflow engine that allows you to define different steps and things you want to do, but not have the user interface be writing a whole bunch of YAML. So there's a bunch of interesting things when you bubble it up to JavaScript that allows you to interpret and build workflows in different ways. And we see a lot of big customers who have non-time critical, so, you know, asynchronous workloads or jobs or job task queues that need to be launched. You could build a CI/CD system with Brigade. However, we know that there are systems out there that do that today. So Brigade, we don't pitch it like that. It's arbitrary workflows that you want to be expressed on Kubernetes, and it's really lightweight and easy to use. Okay, another one is Cloud Native Application Bundles, or Cnab for short. So what we hear in the ecosystem is, hey, it's great, I can package up my application, but then I'm using a different thing to package up my infrastructure to support that application. Wouldn't it be cool if I could put my infrastructure definition, which is Terraform or ARM or whatever tooling you're using, or Pulumi, wouldn't that be great if I put that with my application definition and bundled that up into one thing like a container? So I would have my application and all its dependencies for infrastructure defined in one bundle, wrap that up in a container, and then execute that. So, you know, Cnab sets out to solve, how do I package and distribute my whole application, including its infrastructure dependencies? So if you have that interest, what we see is a lot of ISVs or people in the market trying to package up their software and distribute it to end users that have intrinsic platform dependencies. I need a database over here, I need a Kubernetes cluster there, and then I need to you know, put this Helm chart on top. You can orchestrate all that, and you can provide it as a single package. Cnab also has a really cool installer, if you hark back to installing things on your Mac or PC, where you can actually template and build a UI installer so that you can install your whole distributed app from your desktop. So that's an interesting thing. It also allows for air gap solutions. So if you have disconnected environments where you cannot connect to something like Docker Hub or a container registry, you can actually bundle up the whole app and its dependencies in what we call a thick bundle, put them on a USB stick and move them over to that air-gapped environment. So multiple applications. This area seems to be getting a lot of interest. Cnab is one of the solutions out there in the market that takes a broad look at the whole ecosystem. Some common rebuttal is, hey, we have Helm, why do we need Cnab? Well, there's a world where people, yes, you can use Cnab to spin up Azure resources, absolutely. And there are other plugins to other backends. Azure's just one of them. But what we hear from customers is, I have more than just Kubernetes. My application workload consists of functions, of some VMs, some backend hosted services. What about, you know, what about that? Helm can't take care of that. So, you know, Helm may be one part of a Cnab bundle, it may not, but in a world where your cloud native app may span different runtimes and different interfaces, Cnab is a way that you can package things up. Now that moves me into the next slide, which is Porter. Porter is a tool for interacting and making friendly Cnab. So Cnab is actually just a specification which sets out to define, you know, a common set of interfaces to package up and define your application. Porter is actually a tool which allows you to declaratively do that. So you can specify how you want your application bundled up, how you want the things ordered, and how you want it executed. And that all gets zipped up into a container. And then you can execute it, store it in a container registry, pull it back down and execute it in any container registry today. So Porter is a tool. Again, Porter is in the CNCF as a sandbox project and as you know, a tool to manage Cnab bundle creation and management. The other cool thing is you can define operational verbs for Cnab bundles, for example, install, upgrade, scale, whatever it is for your application. You can define that and outline the workload flow that needs to happen. Okay, Open Service Mesh. This is something we announced back on August 5th of this year. So OSM is a service mesh. So if you're in the service mesh space or have heard about service meshes are out to solve a lot of the problems associated with distributed application management over time. My, you know, catchy tagline is, you don't know you need a service mesh until you deploy your 50th service to Kubernetes. So, and Dave will tell you that putting a service mesh as the first thing onto your AKS or Kubernetes cluster is probably too much too fast. So don't put a service mesh unless you know that you need one and you know the features it provides. OSM is an open source service mesh, which sets out to build on top of Envoy a very lightweight API, which is defined in service mesh interface. And that's a common shared interface that many service meshes provide that implements the bare minimum, most common feature asks in service meshes. So what most customers are looking for with service meshes, in my honest opinion, is end-to-end encryption on their applications at this point, which is MTLS, which is a problem we've created in this distributed applications world where we need security from all our applications, which are spinning up and down all the time. So OSM you could install and have encryption between all your services out of the box for free, and it plugs into things like Azure Key Vault and HashiCorp Vault to do certificate management for your your end-to-end encryption on your services. That's there. You can go and take a look. There's a demo on the repo, and you can go there and take a look. How's the new Docker Compose fit in? I would say this is harking back to Cnab. It's a little orthogonal to Cnab specifically. Docker still has a smaller surface area of backend resources that it supports. Cnab is probably a little broader in what it can support and how it can plug in, which is fine. Compose is suitable for most people who are looking at a narrower scope of infrastructure. But I'd say you could wrap a bunch of Docker Compose up in a Cnab bundle if you needed to tie in different discrete resources that Cnab didn't provide. Docker Compose didn't provide. Sorry. I see people putting some quick starts in there to take a look. Service mesh interface. So I'm going to speak about this briefly, but OSM, Open Service Mesh, is built on Service Mesh Interface. And Service Mesh Interface is, as I said, a standard with the lowest common denominator of different interfaces out there. I see a hand. I'll get to it in a second, just letting you know I see that. Let me just grab the name. I see your hand, Tim, sorry. I will get to you in a second. Service mesh interface, a number of different service meshes out there in the ecosystem implement it. For example, Console, Linkerd, Istio, Rio. There are other ones out there that elude me at the moment. I think even the Nginx mesh implements SMI as well. And the thing you need to know about SMI is that it's just a common interface shared between all service meshes that implement it. And it allows applications and tooling and ecosystem tooling just to implement on one API rather than implementing every service mesh API with their own features. I will pause and take Tim's question. Do you still maybe the hand is down?
Yeah, I think you answered it earlier, actually. He had it in chat.
Okay, cool. No worries. Thanks, Tim. Okay, Gatekeeper. So this is a big project. I heard Dave mention it earlier. So Gatekeeper is around solving policy for Kubernetes. And now what is policy and what does Gatekeeper mean? Policy means a lot of things. So a lot of the times we hear, hey, how do I make sure that only containers come from trusted container registries? How do I make sure developers don't try and pull anything from Docker Hub, for example? They're only pulling from the internal. How do I make sure that all my resources are labeled a specific way? How do I make sure that nobody accidentally puts a load balancer on the internet? I only want to deliver services internal. I don't want to make sure that people don't accidentally put our services on the internet. They're common questions that we hear from customers and community members. And our answer is Gatekeeper. And Gatekeeper is a policy controller, and it allows you to define policy and then at create time. So if a user is trying to create a resource, it will actually throw back error messages if things are out of compliance. It also has an audit mode. So if you're turning it onto a cluster that already has a bunch of established resources, you can define the policy, turn the policy to not enabled or not being enforced. And in the audit capabilities, you can say, here are all the resources that are out of compliance. You can go fix them, clean up the audit log, and then turn the policy onto enforcing. Now, Gatekeeper is actually a project that was donated out of our team to Open Policy Agent, which is in the CNCF. It's going through its graduation pieces right now. So Gatekeeper is there. If you're interested in solving policy or taking a look at what Gatekeeper can do, there's a link there. Dave also mentioned that we have a product that is built on top of Gatekeeper, which allows a more integrated experience if you're in the Azure ecosystem, so that you don't have to install Gatekeeper on your own. And it allows some nicer features so that you can turn policies on using Azure policy and have them implemented on your cluster using Gatekeeper. So that is Gatekeeper. We're seeing a lot of traction in the ecosystem now as people's Kubernetes clusters are getting bigger, and they're like, what actually is going on here? I want to get this back under control. So if you're interested in that space, that's a great tool out there. And if you have customers that are interested in a managed version of Gatekeeper, there is a managed version on Azure called Azure Policy for AKS. CAPI and CAPZ, this is an interesting one. So we still have a bunch of customers that aren't interested in AKS specifically because they want to have more control over their Kubernetes clusters. And one of the things that we're doing for them is we have a tool already out there called AKS Engine, which allows you to build Kubernetes clusters on Azure at the click of a button, but they are IaaS clusters, not hosted managed clusters like AKS. And as I said, this is, there are a few customers who still need this level of granularity and control. The interesting thing is the community is moving to this model called Cluster API, which allows you to declaratively define how your Kubernetes clusters will look in YAML and have that actually built. So it ships with a bunch of controllers that will build and deploy that cluster for you as you have it defined. So think of a YAML file that says, I have a cluster with these nodes and it's this version. You deploy that YAML file and some controllers go and spin up your infrastructure and make sure that it's always in the state that you've declared. We actually show up and do a piece of that project called CAPZ, which is the cluster API provider for Azure. So we make sure that CAPI, if you're using CAPI, integrates well with Azure. Now, I know there are other tools out there in the ecosystem like VMware Tanzu that's leveraging CAPZ. But if you're in the world where you want to build your own Kubernetes clusters via IaaS, this isn't ready for prime time yet. It's something that we're investing heavily in. But if you have any interest in that kind of declarative approach to building your Kubernetes cluster, CAPI, CAPZ may be for you. Time check, Dave. How many minutes do I have left?
Oh, you can keep going.
Keep going?
And,
okay.
Yeah, there was one question around... Yep. OPA and Gatekeeper in here. What would be the best practice approach to enforce sensible defaults to new namespaces, deployments, CPU request limits, security context, network policy?
You can use Azure Policy OPA for this. So you could say, for example, nobody can create namespaces unless they're labeled a certain way. One of the demos I've done before is, let's say you want a namespace to have an owner label or a department label so that you know who created it. So in the event that you want to delete it, you can track down the people that created it. So you can use OPA Gatekeeper to do that. There's another policy that's in Azure Policy for AKS by default. You can say anything without a resource limit or a request or a memory limit, security context. You can lock down any fields to have specific values. And enforce on that. And, they're regexable so that you can match different things there. So, yes, you can absolutely do all those things and enforce them. And you're enforcing them at the user create time. So if your users are using kube control to do kube control create, you can actually enforce them. They'll get an error message back with a sensible error saying, hey, you don't have any CPU requests or limits on your pod. Please do that. You're out of compliance. So you can absolutely do that.
So I'll also mention another tool here that I love is ConfTest. So you can put these OPA policies within like your CI pipeline, so you get feedback sooner rather than at runtime or deployment time. So it's a really cool tool that will evaluate like OPA policies. It can do things like you can do unit tests on like Terraform. So like OPA is something worth like investing your time in kind of learning about it.
And we're working on, Dave, integrating the Gatekeeper built policy structure, which kind of wraps OPA into ConfTest, so you can test them client side as well.
Awesome.
Okay, moving on. This is a really cool tool that we've worked on, but known in the ecosystem still. I think a few people are using it, but there is a Kubernetes extension for VS Code. And if you go and take a look at it, that's something our team built. It allows you to view, manage, control, deploy a whole bunch of bits and pieces with your Kubernetes environment without leaving VS Code. So you can log into Azure, for example. You can actually look at different kube configs that you have, look at those clusters, modify. It does some really cool backend integrations. It also has autocomplete on many of the popular resources, so that if you're typing a deployment, it'll actually give you the field specs and give you context-sensitive tooltips and autocomplete. So that's a cool feature. And you can go and download that today for free. It's just an easy way. You can also port forward, you can connect, you can exec, you can grab all the logs. So everything you can do from kube control, a lot of that is made a lot simpler in VS Code extension for Kubernetes. So feel free to go take a look at that. There's a whole bunch of things you can do. Go take a look. Thanks, Esteban. I'm glad to hear somebody's finding some use in it. So I think it's a great tool. I always demo with it because, yeah, and it can be used from GitHub code spaces as well because it's in VS Code extension. Okay, moving over to something our team didn't exclusively work on, but here is a really cool project out there in the ecosystem that's worth a look if you're in this space. But what Dapper is, so this is a project called Dapper. Dapper allows you to abstract all the complexity that you would need to put in your application code to talk to different backend systems. And what I mean by that, hey, you know, I want to talk to Kafka. I need to talk to an event stream here. You need to actually embed the Kafka client. You need to know a lot about Kafka. And then, you know, as an application developer, that can be extreme. Dapper allows you to have an application-aware environment that knows how to connect to Kafka. So you just need to connect via HTTP to this different backend service, and it will actually funnel everything through to Kafka. So it's a really great way. It basically allows all your services that are available on for your application to be provided in context without you having the overhead of understanding how to connect to those things. So it's a super interesting tool. I'd say go take a look at the different examples I have on the repo. But I think there's a bright future for Dapper, and it allows you to build a lot more tightly integrated microservices without having to understand all the backends. Okay, I see one question as well. Thanks for the answer. Also wondering about actually mutating a deployment to include a default network policy. Mutation is coming in Gatekeeper. It only does validation at the moment, meaning it will not change a field. So mutation is being worked on. If you're interested in helping provide use cases or context for mutation, you can go to the Gatekeeper site, look for the meeting minutes, and show up to one of the meetings and say, hey, I'm really interested in mutating. Here's our use cases. But at the moment, it will not mutate. And by mutate means change a field. So the question was, could I add a network policy if one didn't exist, or, you know, one was defined and it was the wrong one and I wanted to change it? You cannot do that at the moment. Okay, I think there is one other hand up. Okay, I'm going to take a stab at this name. It's going to be Anantha Padmanabhan. Would you like to go with your question?
Hi.
Yeah, hello.
Hello. Thanks for all the useful information. My question was specifically around testing network policies, you know, like some sort of automated unit test. You change global network policy, you know, have namespaces communicate intra Kubernetes and inter Kubernetes, those kind of things. And another one on the service mesh, open service mesh. Is it more of is the purpose more to showcase how the SMI interface should be used and implemented for other service mesh providers, or is there a compelling, does it offer a compelling reason for over others?
So let me start with the second piece on OSM. Yeah, I would say it is a reference of SMI built on Envoy. I don't know, the most compelling differentiators for OSM specifically is it's a very simple, lightweight install experience. So that it ships with a CLI and you can install it in a single command and manage it and upgrade it. The other thing is it's built on Envoy and it only supports SMI. So it's I would say it's a very tightly scoped project that's built on Envoy, and there's nothing else out there in the ecosystem that we found, which is why we worked on OSM. The first question to testing network policy, OPA cannot do that. It can only validate different fields in schemas, so it can't actually test that the of those fields show the correct behavior in network policy. So you could validate fields to be of the right value, but you can't actually test using OPA that the intent of those fields is actually implemented correctly by your network policy provider. Okay, no worries. Thank you for asking. Okay, and yeah, there's a point in there about mutation support within Gatekeeper. The interesting thing is, you know, everybody says you can do mutating webhooks. The challenge is with policy, if you have policy trying to mutate the same field, which field wins? Do you want to merge those fields? Do you want to overwrite? And you can't order mutation in Kubernetes. So whoever mutates a field first will win and change the outcome of the behavior for the next webhook admission controller, because you can have multiple webhook admission controllers. So this means you can have non-deterministic behavior. So your intent of what you wanted to mutate may actually not be exhibited in your output. So on the surface, everybody goes, oh, mutate, it's really simple. But okay, well, we've got two policies mutating the same field. Who wins? We've got two admission webhook controllers installed in the same cluster mutating the same field. Who wins? And what's going to be the output? So that's the challenge. So in a vacuum, I only have one policy mutating one field, and I'm the sole author of all the policies. Super simple. But when you say multiple people are writing policies and there's multiple webhook admission controllers, mutating is really complex and potentially dangerous and error prone. So we're trying to solve it in a sane way, but it's, yeah, on the surface it looks easy, but it's incredibly challenging. Okay, just a few more minutes here. Virtual Kubelet. So Virtual Kubelet actually looks like a Kubernetes on the front end and behaves very differently on the back end, meaning that it's not interacting with a local container runtime. What it actually does is call out different backend services that can run containers on your behalf and make them operationally look like a Kubernetes node. Now, one of the examples we have is ACI. So ACI is a service on Azure Container Instances, which will run a container or effectively a pod on your behalf, but not show you the infrastructure. So it'll just run a container or set of containers on your behalf. So what you can do with Virtual Node is hook it into your cluster and actually scale out onto ACI as an example, rather than building more VMs and attaching it to your cluster. If you just have this capacity that you don't need a VM for, and you have these small workloads that can run up on something like ACI, it has a different cost dynamic. And Virtual Kubelet has different provider plugins for different backends. AWS Fargate is a backend. There are other backends, so you can run Virtual Kubelet anywhere and have it backend to a different hosted service provider. So that's Virtual Kubelet. That is another sandbox project in the CNCF. So I want to wrap up and leave 10 minutes here. Where can you find us? You know, our team, myself, I gave you some information at the start. I'm Lachie Evenson on Twitter. You can ping me on Kubernetes Slack. You can hit me up on many different channels. You'll also find our team in all the communities. We have broad representation across Kubernetes and other projects out there. So our team runs SIG Windows, which is responsible for taking care of getting Windows into Kubernetes, for example. We have people on the CNCF technical oversight committee. So we have broad investment in the ecosystem to help folks out there in the community and customers alike trying to solve that landscape problem that I showed at the start and get solid integration. So feel free to ping us, reach out if you have issues, if you have things that you think might be opportunities. We're always listening, but thank you very much for your time. And I know that was a lot to digest. I will get the slide deck out via David and Kendall, but thank you very much for having me. Is there any other questions? I think there might be one or two, Dave.
Let's see.
Yeah, so OSM specifically is open source. So Envoy, we're using Jaeger as observability tools. So, but all those interfaces have been built to be pluggable. So, you might see things and Azure integrations like Azure Monitor, Azure Application Gateway, Controller later, but they will be plug-in interfaces so that you can choose which different implementation you want to use. Is there any plan for separating AKS API server like Azure App Service for code deployments? It's hard to deploy to AKS from DevOps and enforce restrictions at the same time. I haven't heard of anything. I don't know if anybody else has. It's an interesting request. I haven't heard of anything that we're looking into like that. And I have a generic question on network policy. I was wondering, does it integrate with application security groups in Azure? At the moment, it does not. So defining a Kubernetes network policy does not integrate with security groups in Azure at the moment. Okay, there's a bunch of questions. Dave, I'll let you kind of take the reins here and say thank you.
Yeah, thanks, Lachie. This is definitely great, especially as we talk about some of these different projects more in depth. So it looks like we have some more generic questions. Let's see. Working with AKS API authorized IP ranges in combination with Azure DevOps. Not being able to figure out whitelists for DevOps to be able to create the service connection for the DevOps agent we already run, self-hosted version inside AKS. Yeah, so on that, Azure does publish a wide range of IP addresses for different services, but you start to run into these type of issues even when you're doing like private clusters also, because when you have some type of hosted SaaS service, they don't have essentially a connection to that API. So you have to start running kind of worker nodes within your VNet to be able to get around that. For that specific thing around authorized IP ranges, I believe you would have to look at like the Azure DevOps. I believe they publish what their IP ranges are, and you would have to add that into your authorized IP ranges. Is Azure DevSpaces still supported for AKS? Good question. They just put out the announcement that will be deprecated. I don't believe that deprecation is till 2023 or 2022. But I would probably, if you're just getting started, then I would probably look at Bridge for Kubernetes. I know there's one or two features in Bridge for Kubernetes that was in Azure DevSpaces, not in there in Bridge for Kubernetes. Those things are kind of on the roadmap. But if you're just getting started, I'd probably highly recommend looking at Bridge for Kubernetes because for Azure DevSpaces, it'll be more break fix type patches, security patches like that. New Flux GitOps toolkit will be integrated in Azure. And I guess what sense do you mean? Are you talking about like from Azure Arc, because we use Flux for that? That is something on the roadmap to use Flux v2 within Azure Arc. Currently today it uses the v1 implementation. But if outside of Arc you can use the Flux GitOps toolkit within AKS, that totally works fine. Oh, more questions on Bridge. I'm gonna be honest, I don't know a lot about Bridge. That may be one of our topics in one of our upcoming meetings, because we've had questions each week on that. All right, I believe that is all the questions. Does anybody have any last minute questions? We have 3 minutes. All right. Last comment I'll make is that we are looking at hosting some of these outside of the regular time, because we do have people that we do want to have on call, like Brendan Burns. He'll be doing a session outside of the normal time because he has a reoccurring meeting during this time. So look for those. We will, in the GitHub repo, which I will post right in here, that has all the links to everything for office hours. We will be posting a survey. If you want to add your email address to that survey, that's what we'll do to communicate out when we do host some of these sessions outside the regular time. And as always, please provide any feedback you have on these sessions. If there's topics you're very interested in hearing about, and if you ever want to present something on one of these, we would love to have customers also present. So always feel free to reach out to us. Thanks for joining today, and we'll see you next time.
Thanks.
And
bye-bye.
Thanks again, Lachie.
Thanks, Dave.